Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the Staar exam for 2016 Algebra 1. Alright, let's take a look at number 6. It reads, which expression is equivalent to 2x squared plus 7x plus 4? So we have F, G, H, or none of these. Now, one thing you want to remember is that whenever you're asked to factor a quadratic trinomial, an expression of this nature, there's a possibility that it is prime. What does that mean? There's a possibility that it is not factorable. Okay? So one thing you want to remember is that not all quadratics are factorable. Okay? So if you have a quadratic and you're trying to factor it and it doesn't work, that's okay. That's a prime scenario. Okay, so that's something to keep in mind. Now let's go ahead and take a look at this particular example. We have 2x squared plus 7x plus 4. So we're going to use the x game to factor this quadratic trinomial. The goal is to find two numbers to replace the middle term with so that we can factor by grouping if possible. Okay. Alright, so what we're going to do is we're going to place AC on the bottom, product of A and C, and we'll place B at the bottom. Okay, AC at the top and then B at the bottom. For this quadratic trinomial, A is 2, B is 7, C is 4. Okay, so that follows that A times C is 2 times 4, which is equal to 8. So what we'll do is place 8 up here, and then we know that B is 7. Now what we're going to do is find two numbers who has a product of 8 and a sum of 7. Okay, so let's go ahead and write down the factors of 8, the combination of two numbers that have a product of 8. So we have 8. So what two numbers multiply to give you 8? 1 and 8. Okay, 1 times 8 is 8. And then we also have 2 times 4. Now, are there any of these pair of numbers that can be combined to yield 7, but their product is 8? Let's take a look at 1 and 8 for example. If we have positive 1 and positive 8, the product is 8. The sum is not 7. How about if we make both of them negatives? Their product is still 8, but their sum is what? Negative 1 minus 8 is negative 9. So that combination doesn't work. There's no need to even look at 2, 4 because in this case you have a sum of 6 and a difference of 2. Okay? Since there are no two numbers that multiply to give you 8 and add to give you positive 7, what does that tell us? It tells us that this quadratic trinomial is prime. Okay, let me change the color. This is prime, or in other words, it cannot be factored. Since it's not factorable, the answer to number 6 is option J, none of these. Alright, let's take a look at question number 7. It reads, the graph of 0.5x minus 2y equals 3 is shown on the grid. So we have the graph of this equation here. Question, which ordered pair is in the solution set of 0.5x minus 2y greater than or equal to 3? Okay, now something to keep in mind concerning graphing linear inequalities. If you want to determine the direction to shade of a linear inequality, you will have to, or you will want to express it, the inequality in slope-intercept form first. Okay, so let's write that down. Something to note, this is very important, to determine the direction to shade place the linear inequality in slope-intercept form. Okay, so what is the slope-intercept form that I speak of? Um, Slope-intercept form for a linear inequality is basically y isolated less than or equal to mx plus b, or y isolated greater than or equal to mx plus b for this particular case. Okay, so what we have here is the linear inequality in standard form. Okay, so we have 0.5x minus 2y greater than or equal to 3. So we need to determine what region is going to be our solution region. Is it going to be above or below? Okay. Now, in order to determine that, all we just have to do is get y by itself, and then we'll see which points fall into the feasible region. Okay, so to do that, we will subtract 0.5x from both sides. That leaves us with negative 2y is greater than or equal to negative 0.5x plus 3. And then divide every single term by negative 2. Okay, now this is where you want to be careful. Anytime you divide an inequality by negative, what happens is that the orientation of the inequality reverses. So we have y instead of greater than or equal is going to become less than or equal to. Let's just leave this alone. We don't really need to evaluate this. You could do that with your calculator. Negative 0.5 over negative 2x minus 3 over 2. Less than or equal to, what does that tell us? This less than or equal to provides us with some very valuable information. So less than or equal to tells us that we're going to have a solid line and we're going to shade below. Okay? So what does that mean? It means that any point on the line or below the line will satisfy on the inequality, or in other words, is a solution. Okay? So let's see which of these points either fall on the line or is beneath the line. Okay? So talking about shading, our solution region is going to be down here. So if we shade everything here, including the line, that should satisfy the inequality. Alright, let's start graphing our points. Let's start with point A, negative 2 and 0.5. So negative 2, 1, 2, and 0.5 is right here. That's point A. Point A is no good because it's not on the line or beneath the line. Okay, it doesn't satisfy the solution region. Let's take a look at point B, 2, 1. This is 2, 1. That's point, change the color to red. Point B is right there, positive 2, 1. Is this acceptable or not? The answer is no, because this point is not on or beneath the line. Eliminate point B, 2, 1. How about point C? Point C is 2, positive 1. Nope, 2, negative 1, which is right here. So what's the deal with point C? Is it good? Point C is excellent because it is on the line. It satisfies the equal to component of the inequality. Anytime you have a solid line, any point on that line satisfies the inequality. Let's just take a look at point D. Point D is negative 2, negative 0.5. Negative 2, negative 0.5 is right here. We can clearly see that point D is no good. Point D is not good because this point does not fall on or beneath the line, so we can clearly see that the answer to question 7 is option number letter C. Okay? And if you want to verify, you can just simply plug in these points into this equation here, and you will see that you end up with a true statement. Alright, let's take a look at question 8. It reads, what value of x makes the equation negative 5x minus quantity negative 7 minus 4x equal negative 2 times the quantity 3x minus 4 true. So one thing you can do is you can plug all these into this equation to see which is true, or we can just solve it. Alright, so we're going to go ahead and solve this equation for x and see what answer we arrive with. Okay, so we talked about this in the previous clip concerning distribution. If you have a negative in front, be sure to distribute that negative to every single term in the parentheses. Alright, we'll bring down a negative 5x. In front of this parenthesis we have the invisible 1, which has a negative sign. So what we're going to do is distribute negative 1 to these two numbers in the parentheses. Okay, so that yields positive 7 plus 7 plus 4x. Okay, and then over here the same principle applies. We are going to take negative 2 and distribute it to these two numbers in the parentheses, and that will yield negative 6x minus 2 times positive 4 plus 8. Remember your sign rule. Whenever you multiply signs that are the same, for example plus times plus, you get a plus. And then if you have minus times minus, what do you think you get? You get a plus. Okay, so anytime you multiply the same signs, you get a positive, but if you multiply signs that are different, you get what? You get negative. Okay, so that's a very important rule to remember. The product of identical signs is always positive, and the product of different signs is always negative. Okay, so let's go ahead and continue here. What we're going to do next is combine like terms. Okay, negative 5x can be combined with positive 4x. Now when you're adding or subtracting numbers, if the signs are different, you subtract. So 4 minus 5 is just 1x. And you keep the sign of the bigger one. Negative 5 is bigger, so retain the negativity. Plus 7 equals negative 6x plus 8. Now we're going to collect all the x's to the left side of the equation. First, let's do that. So just add 6x to both sides of the equation. When we add 6x to both sides of the equation, we'll end up with, let's see what we end up with. 5x, signs are different, so we subtract and keep the sign of the bigger, which is positive 6, so we retain the positivity. Plus 7 equals, these add up to 0, 8. Alright, so two more steps to finish off this problem. Get rid of the 7, subtract 7 from both sides, which yields 5x equals positive 1. And the last step is just to get rid of the coefficient of x, which is 5, so divide both sides by 5. And your final answer is going to be 1 over 5. The answer to number 8 is option letter J. Alright, let's take a look at question 9. It says the starting annual salary for an office worker is $29,000. If the company awards an annual increase of 6.2%, which graph models this situation after the office worker receives X annual increases? Okay, so let's start by writing down the formula to guide the construction of our function. Okay, alright. So this is an exponential growth formula because every year you have an increase of 6.2%. So the formula for exponential growth is amount equals the principal times 1 plus the growth rate raised to the t power. Okay, this salary is increased by this percent annually, so it's once a year. That's why we're using this formula. In a function format, we can write this as y of x equals p times 1 plus r raised to the x power. Okay, so the independent variable is your x or your time function. Okay, in this particular case, we're looking at x, the number of annual increases. Now let's go ahead and apply this formula to this particular scenario. We have a principal. The starting amount is P, okay? So the principal is what you start with. So the starting annual salary of the office worker is P, which is 29,000. The growth rate, or the it's called a rate of increase. The rate of increase is our R value, which is 6.2%. Now this has to be converted to decimal form before we input it into the function. 6.2% is 0.062. How did that happen? If you're converting from percent to decimal, you move the decimal point 2 places to the left. Bam, that's how you have 0.062. Alrighty, and then our independent variable, which is the number of increases. Number of increases is x. So number of increase, the exact number of annual increases was not specified. It was basically indicated to be x, so we'll just leave that alone. So we have all the information we need to generate our exponential growth function for this particular scenario. So let's go ahead and do the substitution. So we are going to have y of x equals the starting amount, 29,000, times 1 plus the rate, 0.062 raised to the x power. Let's simplify this a little bit. So y is going to be 29,000 times 1.062 raised to the x power. Alright, so which of these graphs is the graph of this function? Since we're allowed to use a calculator on the test, we can just simply input this graph, this function, into our graphing calculators using the appropriate window, and we will be able to easily determine what the correct answer is. Alright, I'm going to be using a TI-84 Plus to accomplish this task. So let's enter this function. We already have y on the left side, our dependent variable. Y equals 29,000, parenthesis 1.062, raised to the, you see this caret button on the clear, that's how you exponentiate a variable or number, so raised to the x power, enter. Alright, so that's the exponential function we're graphing. So let's go to the window. Now what we're going to do is take a look at the options that we have here. You'll notice that our x, our independent variable, goes from 0 to 10, and the rate of increase is 1. Okay, so x min is going to be 0, the max is 10, and the scaling is 1 because you're going by ones. If you take a look at the range of the function, or the span, the y that's indicated on the window is not the range of the function, just the range of the window that's provided here. The lowest is 0, and the highest is 50,000 for all four options. So 50,000, 50,000. Alright, by what amounts do you go up? 0 to 5,000, 5,000 to 10,000, that's an increase of 5,000, so that's our scale. The reason we are setting up the window in this configuration is we want to have an exact match, or a perfect snapshot of what the graph looks like when it's plotted in the format that's presented. Okay, so let's hit graph. And you can easily see that the correct answer is option letter A. It starts from 30,000, and you see the growth rate. So these are the only two that start from 30,000, but you can see how this one increases rapidly, and this one much more gradual with the increase all the way down. Okay, and then if you look at 9 right here, the output is 50,000. So let's just test it out. So just to show you, so hit trace and then enter 9. and it's kind of sort of like 50,000, 49,833. Okay, so we can clearly see that the answer is option letter A. All right, let's take a look at question 10. It reads, which expression is equivalent to 14a to the fourth, b to the sixth, c to the negative 10 raised to the 8a to the negative 2b to the third, c to the negative fifth power? Okay, so before we start this problem, let's go over or just write down the formulas that will be aiding our simplification of this expression right here. Okay, so we're going to call this the properties of exponents. Okay, you are supposed to know multiple properties of exponents in order to correctly solve this problem. So let's go over them real quick. The first one is the reciprocal property. The reciprocal property just basically indicates that if the exponential value has a negative sign, then that exponential term with a negative exponential value can be reciprocated. Upon reciprocation, the sign changes. Okay, so 1 over x and negative a, if you reciprocate it, they become x to the a, and a becomes positive. Or if you have x to the negative a, this numerator term becomes a denominator term, and the sign of the exponent changes also. Number 2, we have the product property of exponents. Now, what do you do when you're multiplying two exponents with identical bases? All you do is you add the powers. Property number 3 is the quotient property of exponents. When you're dividing two exponents with identical bases, can you guess what you do? Multiply, you add, divide, you subtract. Okay? So whenever you're dividing exponents with the same base, you subtract the powers. So you can either write it as x to the a minus b, or you can write it as 1 over x to the b minus a, depending on which is bigger. Okay, if a is bigger than b, you want to use this format, so you won't end up with a negative exponent. If b is bigger, you use this format, so you won't end up with a negative exponent, which will result in an additional step of reciprocation. Alright, so we're just trying to save time here. Now let us go ahead and solve the problem. We have, let's see what we have, 14 a to the fourth power, b to the sixth power, c to the negative 10 divided by 8a to the negative 2, b to the third, c to the negative 3. Now the first thing we're going to do is address the negativity of the terms with negative exponents using the reciprocal property. Okay, this is 5. Alright, so let's see. C has a negative exponent, a to negative 2 has a negative exponent, and c to the negative fifth. So what's going to happen is that those terms will be reciprocated. Okay, a to the 4, b to the 6 stays. Let's see what's coming upstairs. Well, let's do this. We have 14 a to the 4th. Since this a is going to come up, let's put it over here. It becomes a to the positive 2 power, b to the 6th, c to the negative 5 comes up and becomes c to the 5th power. Okay? And then let's see what's downstairs. In the denominator, we have 8. b has a positive exponent, so we'll leave it alone. And then this c to the negative 10 upstairs comes down, okay, and the power changes. So what did we just do? We just basically took the terms with the negative exponents and we switched the position. So this one, we sent it downstairs, and then this one, we sent it upstairs. Okay, that's all we did. Alright, because of their negative exponents. Now we're going to go ahead and apply the product property and the quotient property of exponents simultaneously. But another thing to note is that 14 and 8 have a common factor, which is 2, so we divide that by 2. We're just reducing the numbers. So if we do that, we're going to have 14 divided by 2 is 7. Now we're going to apply the product property here because we have the product of two exponents with identical bases. So what we do, applying formula 2, we just add the powers. Alright? And then the b's, we have a quotient. The b in the numerator has a bigger power, so we're going to subtract the denominator power from that. What's the story with the c's? We are going to apply the quotient rule there again. But if we come down here, 8 divided by 2 is 4. Now, the c in the denominator has a bigger power, so we're going to subtract the numerator power from the denominator power. Okay, applying the quotient property to dividing these two, we're using this approach right here. So let's go ahead and simplify. We will have 7, a to the 4 plus 2 is 6, b to the 6 minus 3 is 3, divided by 4, c to the 10 minus 5 is 5. So there goes your final answer. As you can see, our answer for number 10 is option letter H. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the STAR test for Algebra 1, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about anything that will be included in the test, just place your questions in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.